Problem 79, we're taking a look at factoring. We're going to be using the sum or difference of cubes, which I'm going to get to in just a second. But the very first problem, we have x to the fifth plus 8x squared y cubed. Very first thing you should always think about when you are factoring is a greatest common factor. Is there any greatest common factors in these two terms? And for this particular problem, there's x to the fifth here and an x squared. So the greatest common factor for this one is actually x squared. So with that, I can rewrite this problem as x squared times whatever is left when I factor that out. So I'm going to get an x cubed plus an 8y cubed. That leaves me with this, which is now a sum of cubes. So in Chapter 8, we had a math notes box, and it looked like this one. So our sum of cubes, we'd sort of derive the formula ourselves, and then the math notes box also gave it to us. So what happens here is if you have a perfect cube plus another perfect cube, your formula is you take the cube root of each to get that one. The sign here stays the same, cube root of that one to get the b. And then once you work with those, you take that and you square it. Your sign flips from what the original was. You take these two things here and multiply them together. And then you take the b and you square it. So we're going to see if we can implement that right now. So I have the x squared on the outside. But then I'm going to take the cube root of this one, which is x. The sign stays the same. And I take the cube root of that, which gives me 2y. Then my trinomial, because it has three terms, is going to be this one squared. Switch the sign from here. These two multiply together. That sign here is always a plus no matter what. So if you look back here, it's a plus in both times when you're doing sum or difference. And then I take this and I square it, which is 4y squared. That is now completely factored. So for problem B, I'm going to take a look at that one. And I do, again, have 8y to the 6th minus 125x to the 3rd. So I do not have any greatest common factors on this one. But I, again, do have perfect cubes. So this is a perfect cube here. This is a perfect cube here. So since I don't have a greatest common factor, I'm not going to get anything out beforehand. But I am going to go through. So taking the cube root of that one is going to give me a 2y squared. Keep the same sign. Cube root of this one is going to be a 5x. Then I square this term, and I get 4y to the 4th. Opposite sign. Multiply these two together, gives me 10xy squared. Always a plus. And then I square this for 25x squared. And that one now is factored. Problem C talks about being a bit tricky, so there's a couple steps here. So I have x to the 6th minus y to the 6th, which is not a difference or a sum of cubes. It is, however, a difference of squares. So I can now go through and write this as a difference of squares. It's going to be x cubed plus y cubed times x cubed minus y cubed. Now once I have that, I now have a sum of cubes and a difference of cubes. So I'm going to be using both formulas. So for the sum of cubes, I'm going to get x plus y times, and now just like I did for the first problem A, I'm going to get an x squared, switch the sign, xy, always a plus, and y squared. For my difference of cubes, I'm going to have an x minus y, because the sign here stays the same, times square, switch the sign, multiply them together, always a plus, and y squared. And that is now completely factored.